The first four terms in the binomial expansion of 3 plus kx to the power of 5 in ascending powers of x can be written as a plus bx plus cx squared plus dx cubed. State the value of a. Given that b equals c, find the value of k, hence find the value of d. So let's have a look at this then. I've got the summary here. 3 plus, let's first of all write this down, what this equals, using the binomial expansion. 3 plus kx to the 5 is equal to summation from r equals 0 to n of ncr 3 to the n minus r times kx to the r. That's what we want, isn't it? That's it there. So now that's equal to, then let's just run along and see what it is. It's nc0, which is 5, because we've got power n is 5 here. So let's put 5 in for n. 5cr, 3 to the 5 minus r, so it'll be 5c naught, 3 to the 5 minus naught is 3 to the 5, kx to the power naught, plus 5c1, 3 to the 4, kx to the 1, plus 5c2, isn't it? 3 cubed, kx squared, plus 5c3, 3 squared, kx cubed, plus 5c4, 3 to the 1 times kx to the 4, and then the last term plus 5c5, 3 to the 0 times kx to the power 5. So there's our series then, written out long-windedly. So state the value of a then. Well, here a was the number of terms, just a constant at the beginning, wasn't it? When you look at this thing here, a is just a number, which is this term here. So part 1, a is equal to 5c0, 5 factorial over 5 factorial 0 factorial, times 3 to the 5. Which is 1 times 3 to the 5, which is 243. Tap it in the calculator if you need to. Part 2. So, given that b equals c, so that would be the term x and x squareds, the coefficients equal one another. So the coefficient in x is here, 5 factorial over 4 factorial 1 factorial. 3c to the 4 is 9 nines 81. Times k is equal to, that would be the b term, is equal to the c term, isn't it, in x squared. 5c2 over 3 factorial 2 factorial. 3 cubed is 27, and then it's k squared. So, what do we get for k then here? Well, the 81 and the 27 will cancel, and there'll be a 3 left here, won't there? The 5 factorials will cancel. Okay, so we've got 4 factorial here. Okay, so we've got 3k over 4 times 3 times 2, 24. So 3k over 24 is equal to, and then what have we got left here? K squared over 2 times 6, which is 12. So that will go into that twice. So, and then we can see what k equals. So k squared minus, I move this 3k over 2 to be with it, equals 0. So I've moved that over there and written it down from right to left. There's just a 3k over 2 left there. So that tells us now then, k outside a bracket, k minus 3 over 2. So k does not equal 0, so that tells us that k is equal to 3 over 2, or 1.5. So there's the value of k for part 2. Hence find the value of d. Given that b equals c, find the value of k, hence find the value of d, which is the coefficient of x cubed. So the x cubed coefficient is here. So for part 3, d is equal to the coefficient of x cubed, which is 5c3, 5 factorial over 2 factorial, 3 factorial. 3 squared is 9. And then k cubed, which is equal to, that will go into that, 5 and 4 left, 20 over 2 is 10. So you've got 90k cubed here, and k is 3 over 2, so that's 3 cubed over 2 cubed, isn't it? Times 90. So you get 90, one of these 2's will go, that'll leave 45, and there'll be a 4 left here now. So it's 45 times 27 over 4. So let's type that in the calculator then. 45 times 27 divided by 4 equals 1215 over 4. So d is equal to 1215 over 4.